Good morning, students. Today topic is statistical inference and estimation. Statistical inference provides us how to estimate a value from the sample and test that value for the population. Now we are going to take EX number 8.2. Question number 1 mention two branches of statistical inference. The two branches of statistical inference are number 1 estimation, number 2 testing of hypothesis. Question number 2. What is an estimator? An estimator is a sample statistic used to estimate a population parameter. Number 3. What is an estimate? An estimate is a specific observed value of a statistic. Number 4. What is the point estimation? An estimate of a population parameter given by a single number is called as point estimation. 5. What is the interval estimation? We are interested in finding the limits within which the parameter would be expected to lie is called an interval estimation. Number 6. What is confidence interval? The interval, closed interval C1, C2, within which the unknown value of the population parameter is expected to lie is known as confidence interval. Question number 7. What is the null hypothesis? Give an example. Null hypothesis is the hypothesis which is a tested for the possible rejection under the assumption that it is true and it is denoted by H0. Next example. Suppose we want to find the population mean as a specified value mu0. Then the null hypothesis H0 is H0, mu is mu0. Next, question number 8. Define alternate hypothesis. Alternate hypothesis means H1. Okay, any hypothesis which is the complementation to the null hypothesis is called as the alternate hypothesis and it is denoted by H1. 9. Define critical region. A region corresponding to a test statistic in the sample space which tends to rejection of H0 is called critical region. H0 means the null hypothesis. Next, question number 10. Define critical value. The value of the test statistic which separates the critical region and the acceptance region is called the critical value. Next, question number 11. Define the level of significance. The probability of type number 1 error is known as the level of significance. Question number 12. What is type 1 error? The error of rejection H0 when it is true is type 1 error. Question number 13. What is single failed test? When the hypothesis about the population parameter is rejected only for the value of sample statistic falling into one of the fails of sampling distribution, then it is known as one failed test. Question number 14. A sample of items draw from a sample of 100 items draw from a universe with mean value 4 and standard deviation 3 as a mean value 63.5 is the difference in the mean significance. sample size is 100. Sample size n is equal to 100. Next is sample mean. Sample mean x bar is equal to 3.5. Next, population mean. Population mean mu is equal to 4. Population standard deviation. Sigma is equal to 3. First, number 1 null hypothesis, number 2 alternate hypothesis, number 3 inference. First, null hypothesis. Null hypothesis H0. Mu is equal to 4. Next, alternate hypothesis. Alternate hypothesis H1. H1 is equal to H1 is mu is not equal to 4. Null hypothesis mu is equal to 4. Alternate hypothesis mu is not equal to 4. The level of significance. The level of significance alpha is equal to 5%. 5% means 5 by 100 is equal to 0.05. Apply the test. Apply the test of statistic. Is equal to x bar minus mu divided by sigma divided by root n is equal to x bar is 3.5, mu is 4 divided by 3 divided by root 100 is equal to minus 0.5 divided by 3 by 10 is equal to minus 0.5 divided by 0.3. This means multiply numerator and denominator by 10, we get 5 by 3 minus 5 by 3 into 10 divided by 10 gives. This means minus 1.667. Next, is equal to 1.667. Next, the table value. The table value is at n by 2 is equal to 1.96. This case Z is less than Zn by 2. It is 1.667 less than 1.96. Next, inference. Since Z is less than Zn by 2 at 5% level of significance. Level of significance. Therefore, there is no significant different in the mean significance. In the a sample of individuals formed to have a mean height of 67.47 inches, can it be reasonably regarded on a sample from a large population with mean height of 67.39 inches and the standard deviation is 1.30 inches. First, sample size. Sample size n is equal to sample size n is in this case 400. Next, sample mean. Sample mean capital X bar is equal to 67.47 inches. Next, population mean. Population mean mu is equal to 67.39. 67.39 inches. Next, population standard deviation sigma is equal to 1.30 inches. Next, null hypothesis. H naught mu is equal to 67.39. Next, alternate hypothesis. Mu is not equal to 67.39. The level of significance alpha is equal to 5%. 5% means 5 divided by 100 is equal to 0.05. Next, is equal to x bar minus mu divided by sigma by root n is equal to 67.47 minus 67.39 divided by 1.30 divided by root of 400 is equal to 0.08 divided by 1.30 by 20 is equal to 0.08 divided by 0.065 is equal to 1.30 2308. Mod z is equal to 1.2308. The significant value is at n by 2 is equal to 1.96 from the table. Z is less than Zn by 2. 1.2308 is less than 1.96. Next, inference. Zn by 2 at 5% level of significance. The null hypothesis mu naught is accepted. We can conclude that the sample from a large population with mean height (67.39) and standard deviation 1.30 inches. The mean breaking strength of cables supplied by manufacturers is 1800 with a standard deviation 100. By a new technique in the manufacturing process, it is claimed that the breaking strength of the cables has increased. In order to test this claim, a sample of 50 cables is tested. It is found that the mean breaking strength is 1850. Can you support that claim at the 0.01 level of significance? First, sample size. Sample size n is equal to 50. Sample size n is equal to 50. Next, sample mean. Sample mean mu is equal to 1800. Population mean. No, this is X bar. Population mean mu is equal to 1850. The population mean mu is equal to 1800. The population standard deviation is sigma is equal to 100. First, null hypothesis. H naught is equal to 1800. Next, alternate hypothesis. H1. Alternative hypothesis H1 is mu is not equal to 1800. Next, level of significance. Alpha is equal to 1% is equal to 0.01. Apply the test of statistic. Apply the test of statistic. Z is equal to x power minus mu divided by sigma by root n minus mu is 1800 divided by 100 divided by root 50 is equal to 50 divided by 100 divided by root of 50. Root 50 is 7.07 is equal to 50 divided by 14.144 is equal to 3.535 using the calculator. The significant value n by 2 is 3.58. Here Z is less than Zn by 2. So 3.535 less than 3.58. Inference. Z is less than, since Z is less than Zn by 2 at 1% level of significance. Level of significance. Next, the null hypothesis. The null hypothesis H naught is rejected. Here we conclude that hence we conclude that mu is not equal to 1800 we cannot supply we cannot supply, no, we cannot support, we cannot support that climate 0.01 level of significance. Today homework, EX number 8.2, sum number 16. Sum number 16 is same as sum number 17. Okay, any doubt? Reply the message. Thank you.